exploiting McDonald's APIs to hijack deliveries and order food for a penny. API flaws in the McDonald's delivery system in India, one of the world's most popular food delivery apps. That is low-key concerning. I am shocked that it's that popular in India. I feel like people in India are fairly healthy, and I feel like if you're eating McDonald's exclusively, you are not going to be that way for a long time. So a variety of fun exploits, the ability to order any number of food items for 1 rupee, which is 1 US cent. The ability to steal, hijack, redirect other people's deliveries through a specific sequence of carefully timed API calls, retrieve details of any order, track the order in the on-the-way status, download invoices for any order, submit feedback for orders that are not your own, the ability to view admin KPI reports, and sensitive driver information. That is crazy. Okay. Everyone reading this knows about McDonald's and maybe even had breakfast there on the way to work today. I did not do that. I stopped eating McDonald's about 5 years ago because when I did eat McDonald's, I wanted to die violently, like within a couple hours. I used to enjoy McDonald's Happy Meals and sometimes avoid playing the play place while I eat there frequently nowadays, same. McDonald's is usually my top pick for a safe, reliable bite to eat while traveling. In recent months, I decided to try my hand in finding exploits in the food industry. That's an interesting transition. How do we go from I like to eat McDonald's to let's hack the food industry? Very interesting transition. McDonald's USA does not have an official bug bounty program, so I didn't bother with them. McDonald's in India, however, does. I wonder why one does versus the other. You would think at like a global level, they're probably ran by like different corporations in different countries and stuff, but you would think that one would have it like kind of broad scope across the entire globe. So that's where I began my search. What follows is exciting experience in helping one of the world's most iconic brands fix security problems before malicious hackers take a bite out of them. Look at this guy. Look at this guy with his use of language for eating. McDonald's India, specifically McDonald's India West and South, Hardcastle Restaurants Private Limited, own and operate McDonald's restaurants across West and South India. They also operate a system called McDelivery, which, as you can guess, lets people order McDonald's for delivery. You can order food for dine-in and takeout as well. McDelivery is also available in many other countries, but India has developed their own custom web app that is unique to them. Interesting. Okay. McDelivery is available online at delivery.co.india and through mobile apps. It currently has more than 10 million downloads on Google Play. That's actually crazy. And is number 16 in food to drink on the Apple App Store. It's extremely popular. Yeah, I guess that means that like Uber Eats and like DoorDash equivalents are not popular in India, because in the US, like first of all, if you're DoorDashing McDonald's, question your activities. Consider yourself lost. But I mean, okay, if you have to do that, that's fine. You know, the fact that they have this in India means they don't have that option for DoorDash. Very interesting. McDelivery is no stranger to security problems. Back in 2017, there was an incident that leaked user data. It looks like nothing notable has happened since then, so the security seems to have held up until I started tearing it apart. I'm curious what this incident is. McDonald's India delivery app leaks user data. Is there any detail? Details of 2.2 million users. That's pretty bad. That's pretty bad. The McDelivery website and mobile apps are built using Angular, a popular single-page application framework. It is a good fit for this type of high-interactivity consumer-facing app. The first order of business was to look for some routes to see what kind of functionality the web app offered. It didn't take long to find interesting routes related to the orders. Hey, listen up. Not a shameless plug or anything, but Low Level Academy is built on React. But I also do know that there are routes also in React. I'm not a front-end programmer. That's what I'm just gonna stop talking now. So it didn't take long to find interesting routes related to the orders. Interesting. So I'm kind of shocked that Angular, again, not that this isn't like sensitive information, right? There's nothing sensitive about this information. Like it's all front end, it's all being rendered to the user. But the fact that it very like explicitly just shows you, hey, here are all of the paths is very interesting. Again, security through obscurity is not security. Like obfuscating this wouldn't help at all, but you would think there'd be a better job of like, if you're trying to hide things from the user, maybe not show them this, but also like the filtering should be done on the back end. So maybe this isn't a big deal. Let's see actually what happens. At this point, I had no idea what order cart or user IDs looked like. In these situations, I tend to try 0 or 1 to test whether they are simple integer values. In the browser address bar, I put in the order tracking route with the values for order ID, cart ID, and user ID. Let's see if we can see this here. Order tracking, yep, order ID, cart ID, user ID. Lo and behold, I got a result. Oh God, look at this, literally in the URL, order tracking 100, which would mean it's what, order 1, order 1, cart 0, user 0. Shocking that returned something. That's very interesting. Okay, is that not the coolest animation? That's also very concerning, and that someone ordered online breakfast McDonald's. Question question yourself. I was shocked at how easy this was. The type of vulnerability is called a broken object level authorization, or a BOLA. Yeah, that makes Ebola. Holy shit. A BOLA, not an Ebola. Those are different things. This is a very common vulnerability that I see all the time. Many BOLAs were found in McDelivery. Guys, I feel like I'm on drugs with the words that I'm saying out of my mouth right now. McDelivery, BOLA, Ebola, like what? Relax. We gotta reel it in. Epicurious broken object level auth. Yes, BOLA. Digging into the code and network activity on the site, I found that ultimately only the order ID mattered, which had been set to 1. It's used in 2 requests. First, the order status. This had basic information about the order, nothing particularly sensitive here. And second, the order location. Okay, I'm gonna call something out real quick. The fact that the user ID does not matter, but is included in the URL like template, to me indicates that like they meant to add BOLA authentication to associate a user to an order, but just never got around to it and like forgot about it. And then like it worked. Like in the back end, when you go retrieve your order, it doesn't break, so who cares, right? But then when people go to retrieve other people's orders, it crosses a security vulnerability. But let's see what they have to say. Order IDs are sequential, meaning you can keep adding 1 to the number and get the details of the next order, and in turn get even more user information. Yeah, so literally he could just enumerate the entire database right here, like just and get all of the details of the users. That's actually insane. One thing that struck out in these API calls was a JSON web token, the JWT token. Yes, the JSON web token. At this point, I have not created an account and was not logged in. The token came from a guest login API that runs in the background when you load the website. So a separate subdomain gives you a token, I'm assuming, guest ID equals blah. It's always good to see sort of auth token being used with APIs. You'd be surprised how many huge corporations forget to utilize one. However, despite there being valid auth in this case, something seems amiss since I, a guest user, was able to access order details of another user. Yeah, so it's like they're doing JWT to get you access to the API, but not doing any authentication in the back end to like confirm that it actually matches the order you're looking at. Golden reviews. I started incrementing that the order ID and noticed that order ID 6 had a new section where you can leave feedback on your order. The previous orders were already reviewed and number 6 was not. These early test orders were made by developers, so I decided to try and leave a review to see if it would be accepted. And the API was happy to accept my review. Okay, so like at this point, he's kind of hinted at like, there is no authentication between orders. Okay, so let's see what the response is here. So remark equals, it wouldn't be a bug brownie without a hash brown, store ID 101. Yeah, so very interesting. Then I tweaked the API call a bit to try to retrieve the last review before mine. The response to the API call included an ID which serves as the ID for the review I just left. I subtracted 1 from that number and fired off a new API request. It was successful. Technically, it is still using JWT for authentication. Did the requirement say it had to do so correctly? Yeah, like they're reading through the contract. They're like, hold on, Yeah, the contract says JWT. We're using JWT, but you didn't say I had to authenticate everything. So I don't know if we're in violation of contract, guys. Sorry about that. Mapping and delivery. Going back to the Angular routes, the next one I wanted to try was the rider tracking. This one also takes an order ID. The page functions as a real-time tracking system that shows the location of your delivery driver. The page wouldn't work with the test orders 1 or 6 because those were delivered long ago. I needed a real order, one that was on the way right now. The other feedback API I just played with contained the solution. When I retrieved the last review before mine, it contained a vital clue, the order ID. I now had a starting point to try and find the latest orders. A lot of ID manipulation later, I eventually found one that was on the way. Dude, this is actually low-key terrifying. The guy can just figure out like, oh, where's the driver? He probably has food. What if I held him at gunpoint for my free McDonald's? No one would actually do that, right? But I just like the point being that you know where this guy is, and that's probably not what he signed up for when he signed up to be a driver. It's like, the people can see where their food is and the app can see where the food is, but maybe not everyone else outside of the app. And just like the order tracking page, there's an underlying API that provides the latitude and longitude of the driver. It also provides some extra information like their phone number, email, name, and license plate number. Holy shit, dude. What? Yo, okay. You can easily repeat this request for different order IDs to collect personal information about various drivers, and to include their license plate numbers. Oh, that's really secure. Nice job. Check please. I noticed on the order tracking page, the invoice link would trigger an API call to download the original invoice for the order. Additionally, digging around in the JavaScript code, I found a second API to generate an invoice in a slightly different format. Both are vulnerable to order ID manipulation, so it was possible to download the invoice of any order. Again, you are revealing a lot of info here about and then you could use the contents here to go back and query the API for other stuff. It's just crazy. That's so uncomfortable. Oh, yeah, okay, this is the PDF content, all right? Oh, with the phone number, very good. Creating an account. Creating a McDelivery account requires an Indian phone number to retrieve a verification code. Despite my best efforts, I could not successfully create an account this way. Without an account, you couldn't actually place an order, so the research was about to end here, until I found a secret user creation API. Oh, so not only is this not using any authentication, they have a backdoor. Obviously, that's what we all want. On a whim, I sent a GET request to the root auth API path, and it returned a small list of API endpoints. You just do API v1 docs user ID. Yeah, exactly. You just it's docs as a service. It's DAS. Let's see here. Wait, what is the path here? It's /auth, and it JSON returns a. Oh, interesting. I mean, it's not like a secret API. It looks like they're using a different authentication provider, because this is the same URL that returned the JWT, right? The JSON web token for the auth. So this is just like probably the default way that the JSON web token provider is able to handle new users, but they didn't like firewall off that URL. The user create API is one of the most interesting because it was different than the normal signup flow, and it was not used anywhere in the app. Yeah, so it literally seems like they're using another, like an auth provider, and they did not close down the user creation methods here. Since there was no reference material for crafting a valid request, I had to figure it out myself. Fortunately, an empty post request prompted the API to tell me what I expected. Wonderful. I love that, dude. When you're doing like API fuzzing and stuff, and you, like, again, the problem with web pen testing is it's a black box, right? You can't get the code unless you hack the server, which is like the whole point of it. So you do these pen tests, and you're like, okay, it's an opaque field with like a JSON blob. I got to figure out how to actually do it. But when it tells you, hey, can you specify these two very opaque fields, but I'll tell you the name and the format, you're like, oh, thank God. Thank God. Field required, primary contact required. Okay, I was able to successfully create an account without any verification needed. That's so cool. This was a key first step, but only half the journey. While this made it possible to create an account, the login worked via verification code. So it still wasn't possible to log in at this point without a way to retrieve the code. The final clue came when looking at the routes one more time. A hidden auth with password page exists that made it possible to log in using a password. Despite the placeholder text, the page was fully functional and was able to log in. Okay, just more backdoors. How is this allowed in production? Yeah, dude, I don't know, man. Again, like a lot of what my channel is highlighting code that like should not have made it out the door. And this is just another case. Join the Discord seems fun. My Discord or their Discord? Hold on, which Discord seems fun to you? Why does it seem fun? I'm very concerned. Hold on a minute. Again, I would not put your personal details here, man. Just gonna say, not super sure you should be doing that. Jayatan is loving this architecture style. The big bite, ordering anything for a penny. With an account in hand, it was now possible to get to the good stuff, the order checkout flow. I am so hungry. I'm probably gonna leave stream after I end this to go eat McDonald's and hate myself. At this point, I had already had some significant findings, but I was still hungry for a second helping. Please stop. Man, I'm so hungry. Getting started, you are asked to confirm your location. A map is displayed. You have to place a pin. I'm going to choose my imaginary yacht. Same, me right there, just off the coast of Mumbai. Yep, 100%. Then you simply browse the menu and add whatever you'd like to your cart. I'm a generous host on my imaginary yacht, so I decided to get everyone hash browns and a special drink for me. I love McDonald's hash browns and everyone else does too, right? How many? Yo, homie got 100 hash browns? Hold on, what? Can you spot the problem? Let's see. At the bottom right, it says selected address is not serviceable. Oh yeah, because bro is in the ocean. Sorry, I forgot about that. Bro put himself on a yacht, so he, yes, probably cannot service that address. I was heartbroken and thought about seeing if KFC would take my money instead, but Angular apps are meant to be broken. So I did a simple trick and removed the disabled attribute from the button, and that did the job, guys. There's no way. There's no way. There's no way. No. I have to go on a quick rant real quick, okay? First of all, let me be very clear. I am not a back-end developer. I am not a front-end developer. I'm a security engineer and vulnerability researcher, okay? So this is not my day job. But I will say that the front end of an application should just be an untrusted representation of the backend, right? The backend has the state is presented to the browser renders the state, okay? If there were to be a thing that is disabled, you use HTML and CSS or whatever to undisable the disable, right? So you delete it. But if you then send a request to a thing that is not disabled, I swear to God, the backend better verify it, because if it doesn't, I don't know what you're doing. I'm for the smell test here is that it's going to work anyway, and I don't know how I'm going to feel about it. So it just lets them deliver to the ocean. Which again, isn't a huge deal as long as the back end is like properly enforcing that logic. I was able to click the button now and redirected it to the payment processor. No shot, dude. And now I had a new problem. It's too expensive. That's about $68 US. I wanted the discount. Hold on, you get 100 hash browns for $68? I'm kind of hungry. Okay, let's go through the order process step by step. Cart and items. There really aren't any surprises with this. When you add an item to your cart, a cart is created first. If you don't have an active one, a cart is represented by a GUID. Yep. Once a cart is created, you add items using the item's ID to your cart object. It's simple and a very common design. Yeah, that makes sense, right? Like, bro is actually going to edit the metadata for the order. Dude, he literally might. Let's see. Order and checkout. When you are done adding to cart and want to pay, you go to the checkout page, you review the items and the total. Using the cart ID, a post request is made to an orders API. And that API returns information that is used to redirect the just pay for payment. No. Oh, God. Okay. Oh, God. What I'm pretty sure is happening here, just based off what he said, you get the contents of the request from the actual McDonald's app. It says how much the stuff costs in the user side, and then the user sends the request to the payment processor. So I think if you're able to just literally modify the contents via burp of how much the food costs, you can tell JustPay that it only costs a cent, and then you're done. They contain the payment info. I looked at the possibility of editing the amount field there. Also, if you had another user account's ID, I thought maybe you could put it in there and use someone else's stored payment method to pay for an order. That's actually 5head. Unfortunately, all attempts at modifying these fields failed, and here's why. There is a signature that covers the order details. That contains all the key values that need to be modified for any fun to be had. Thank God, dude. Okay, I was gonna say, if McDonald's was sending you the contents of the order and the price, and you were able to just send that up to the payment processor, if they weren't doing signatures, I was going to cry softly into my hands. But okay, so they actually are doing some sane amount of work. There are some fields outside of the order details, but changing them did not produce expected results. The signature is generated this like server code. The orders API accepts your cart ID and extracts all the needed information from the cart object. The order details object is created, and the RSA signature is created based on that. Both are returned to the client. Good. This is an example of good design because it ensures the client can't tamper with important values like the amount of money to pay. This is huge. Okay, I was very nervous they were just gonna be like, yeah, hey, can you just go give this to the payment processor, please, and like not sign it? But this is good. I was starting to believe that this was a dead end. The developers did this part right, and it was very unlikely it would be possible to exfiltrate the RSA private key. Okay, here's the thing. When you're doing vulnerability research, when you're doing pen testing, we have this thing called code smell, right? You use code smell to kind of determine, is it worth spending more time on? Is it worth putting more energy into, right? And so far, the code smell of this article has been a fucking fish market, okay? So I hear what he's saying, right? Like, you don't want to spend too much time on dead ends. You see good crypto happening, so like, okay, maybe the good crypto is fine, right? But that being said, the rest of the article indicates that there are probably mistakes in this implementation as well. Any hope of success would involve tampering with data before the signing take place. I take a step back and look at the cart object and had an idea in mind. The cart object was able to accept item updates, but could it accept price updates too? Oh no, okay. I put together a put request to update the price. Surprisingly, it worked. This type of vulnerability is called a broken object property level authorization or mass assignment. Unlike BOLA, wait, broken object property level authorization. Yeah, okay. Unlike BOLA, this is a very uncommon vulnerability that I have never usually have success in finding or exploiting. Yeah, 100%. The fact that you're able to just, hey, can you guys change this contents for me? And it's like, yeah, it's a BOLA. Yeah, exactly. It seems it was possible to update most delivery objects and fields in this way, opening the door to lots of possibilities. I tempered my excitement for a moment because there was still a good chance that the server would recalculate the price before creating the order details object and signing it. Yes, you would think it would go through, it would validate that the prices actually match the database prices and then give it to you signed. The only way to test the checkout was to check out again. I went through the checkout again, and the order creation now looks extremely promising with the, I don't know if you can see that because of the small text here, but the amount of the order is 1.0. It's 1 rupee, right? Or one US cent. Order details contains our custom price, and we have a valid signature for it. The Just Pay checkout will happily accept this. The cheap price also enabled a new cash on delivery payment method, which made it easier to complete the checkout. Holy shit, dude. That is so crazy. I decided to try to complete the checkout. I found a cancellation API I could use to quickly cancel it before the order got too far along. The checkout succeeded as expected. Dude, some poor bro is making 100 hash browns to send to 1337, the location. A question you may have is, would the order have actually been delivered were it not canceled? I believe it would have been if you gave a correct address and didn't go overboard with the items. Okay, so this guy's actually a homie and didn't make it so that someone had to prepare this order, because that's kind of a dick move. I surely would not go to McDonald's in 30 minutes and order 100 hash browns. That'd be crazy. It is also worth noting that the price of 0 did not work because JustPay requires a value greater than 0 for the amount, so it was not possible to order anything for free. Stealing someone else's order. Oh no, dude, the conclusion. Still a little hungry. I wanted to see if it was possible to redirect someone else's in-progress order to my address or have somebody else pay for mine. I created another account for this test. I did not test against any real users. It was important to not cause any disruption to legit orders and not defraud or phish anyone. Dude, absolutely based researcher, right? He's like, not only have I found ways to subvert the entire architecture of your design, I'm not gonna steal from you guys because I have morals. Love that. First thing I tried was an edit to the user ID in the cart object. The API accepted the change, but it resulted in an internal server error while checking out. Dude, some poor server architect is watching these 500s hit the log and trying to figure out what's happening. And it's just they didn't account for the logic that you can change the user ID of a user. I didn't have any other ideas for trying to gain access to the user's payment options to pay for my order, so I moved on to trying to redirect an existing order. The goal for this test was to try to update an order placed on another account in a way to get it sent to my address instead of theirs. Also in a way that would be powerless to stop. I have 2 accounts ready for this. Consider account 1 my account and account 2 the victim. Both accounts need an address in their address book, so I chose random ones. Okay, cool. Payment rug pull. The victim then creates an order and is redirected to JustPay to pay. Before they enter their payment information and confirm the payment, my account will do a put request on the victim account's order to replace their address ID with mine. The API response includes a new address ID indicating success. Brother. I mean, again, I'm not surprised by this given the contents of the earlier part of the article, right? But literally able to time of check, time of use, inject a new address. Okay. After that, the victim pays for the order, not knowing the address has just been changed behind the scenes. But if they go into their order history and view more details, they may notice the address is wrong. To be clear, this exploit is very time-based. You have to find the order. Exactly. You would have to know that someone has just ordered, that you have their order ID, and to update their order to your address, right? Very time-dependent, but still great impact nonetheless. And then the takeout, to prevent the user from noticing the change and potentially canceling the order, there's an optional step to reassign the order to my account. This is done through another put request on the order to change the user ID to my accounts. Startup idea for a browser plugin? What, to just nuclear detonate the McDelivery India admin panel? Admin panel. An admin panel for McDelivery exists at I guess something management system, McDelivery Co. India, and it seems it is more secure than the consumer website. I couldn't find any way to get inside, but I did find an admin endpoint to view their KPI reports that accepted consumer JWT tokens. Wow, that's crazy. So it's just hey, are you authenticated anywhere? Okay, great. The guy just blazed over, oh, I might as well take over your account. Yeah, exactly. All the other APIs rejected the token due to confidentiality. KPI numbers cannot be shared, so please don't ask it. That makes sense. Again, dude, good for this guy for not leaking sensitive stuff. Let's see what the timeline is. So they put this 24-page report to the McDelivery bug bounty. Again, I feel like I'm on LSD or something talking about this right now, like McDelivery bug bounty program. We are going to tell McDonald's about the bugs. The overall interaction was positive. Thanks to the comprehensive detail in my report, they fixed everything correctly. Awesome the first time with no additional information needed for me. I was impressed, but everything was resolved within the standard 90-day time frame, and a bounty was awarded. Glorious. You love to see it. I would also like to specifically call out the fact that the bug bounty does exist for the system is awesome. McDonald's USA does not care enough to make an official bug bounty program. Even HackerOne called them out on it. Yeah, dude, it's such a net positive for your organization to have a bug bounty program, because if you're willing to pay people to find bugs in your software, trust me, A, they will find the bugs, and B, they have a incentive other than extortion to find and mitigate the bugs, right? You pay someone $1,000 to find the auth bypass that would have taken down your system, right? It's a net large W for everybody. Why not use a pen testing company? They just tend to have more overhead. It just depends on what you want, right? If you want a singular event where a pen testing company comes in and they find all your flaws and give you a report on how to mitigate it, that's an option. Sometimes having more of a overtime bug bounty program where certain things are in scope, you don't know exactly what you want tested, you don't know exactly how long you want it tested for, but more generalized is a good time to just have a bug bounty program too. Bug bounty is also way cheaper than an org from a security aware product manager. Yeah, exactly too. Bug bounties are way cheaper than having like redteam.ai come in and like nuke all your stuff. It's interesting, McDonald's India takes security more seriously. While such severe flaws were surprising to be seen in a mature system that has been around for many years, I'm glad they had the foresight to create a bug bounty program. Many other companies can learn from them. So let's see what the timeline is here. Report sent in July, acknowledgement, follow-up. It's about a month to verification. Development still ongoing. Check the issues, determine they're all fixed in September. Wow. Confirmation that all the reported issues are fixed, and they gave him a $240 Amazon gift card. Here's the thing. I don't know where this guy is from. I don't know what country he's from. I feel like that's not enough money. And again, it's India, right? So what is that? That's 24,000 rupees, according to the conversion rate from up above. Yeah, a wee bit cheaper than a pen test. Yeah, exactly. Like it's like a little cheaper, like a lot cheaper. It probably took him over a week to put all that stuff together. Yeah, that's the thing. Like he wrote a 24-page report, like maybe a little, but again, I don't know about the economics of how much money this actually turns into in India, right? So I'm not gonna like complain about that. Either way, the fact that he got paid at all is huge. Yeah, man, I mean, there's a few things that I have to say about this, right? Like, first of all, if you are ever developing a web app and you're nervous that it's not good enough, I would say just keep going, just keep learning. You are going to make mistakes. Everyone makes mistakes. Not that these are acceptable bugs, right? These are blasphemous bugs, but like people make mistakes. Keep coding, okay? 2, props to this guy for doing vulnerability research in a way that was so cognizant of not causing disruptions in their system. That's how we keep bug bounties alive, right? There's a huge problem that people run into when they have bug bounties, and people just go willy-nilly and fucking Wild West it and stuff, and like you don't want that because it gives the industry a bad look. And then also, man, congratulations. First of all, amazing article, amazing write-up on this, and congratulations on your $240. Guys, if you like videos like this, I love reacting to this kind of stuff. I love these articles. They're super fun for me. I hope you enjoy them as well. If you do me a favor, let me know in the comments down below, and then go check out this video about a very similar issue that someone found in a huge piece of software. We'll see you there.